Example 3C. Let's start solving using Gauss-Jordan elimination. All right, so first thing we're going to do, change this system into a matrix. Okay, so our first matrix, let's write down the first row, 3 in front of x, 7 in front of y, -1 in front of z, and then an 11 on the other side. Okay, second equation, 1 in front of x, 2 in front of y, -1 in front of z, 3 on the other side. Okay, last row, you should get a 2, 4, -2, 10. Okay, all right, let's start solving the system. Okay, we are going to start in the first column. We want to secure a 1 on the principal diagonal. Okay, so you have two options. Try to switch rows, okay, or multiply or divide this row through by a non-zero number. Okay, if luckily here we can switch rows. If we switch rows 1 and 2, okay, that will put a 1 here. Okay, that's our best bet. Okay, because the alternative dividing row 1 by 3, 3 divided by 3 will give you the 1, that's going to introduce fractions. Okay, so we can avoid the fractions here. Okay, so our next matrix, okay, we are simply going to switch rows 1 and 2 to get it. Okay, all right, so let's see here. Oops, trying to keep the colors straight for you. Okay, so let's see here. Row 3 is going to stay the same. Okay, so I'm going to go ahead and leave row 3 alone. Okay, and then let's see, switch rows 1 and 2. So the first row will now become the second row. Okay, so you're switching the entire row. Okay, and then what was the second row will now become the first row. Okay, so there we go. We have our 1 on the principal diagonal. Okay, all right, keep working in this column. Okay, so now we need to zero out the rest of the column. Okay, so let's change this 3 to a 0. Okay, gonna have to do the third row operation here. Okay, we are in the first column, so that means we need to multiply the first row by something. Okay, to cancel a +3, we need to use a -3 to cancel it. Okay, so we're going to multiply the first row by -3. -3 times 1 will give you -3 right here. Okay, add it back to the second row, you'll get your 0. Okay, so to get the third matrix here, okay, our row operation is going to be -3 times the first row, add it back to the second row. That's going to be the new second row. Okay, all right, so for our new matrix, okay, row 1 stays put, doesn't change at all. Okay, and row 3 also stays the same. So write that down. And now we're going to go out to the side and do the work for the new row 2. Okay, so I'm going to do -3 times row 1. Okay, so we need to multiply every element in row 1 by -3. Okay, so that's going to give us -3, -6, negative times negative is +3, and then another -9 here. Okay, add back to it row 2. So go to the previous matrix and write down row 2. All right, and there we go. So we add. Okay, so we're going to get 0, -6 plus 7 is +1. 3 plus a -1 is the same as 3 minus 1. That's 2. -9 plus 11 is +2. Okay, so here is my new second row. All right, continuing on in the first column. Now I've got to zero out this 2. Okay, all right, so again, third row operation here. Okay, I want to get rid of a 2. Okay, what's going to cancel a 2? A -2. Okay, so since we are in the first column, we still need to multiply row 1 by something. Okay, we're going to do -2 times row 1. Okay, -2 times row 1, or -2 times 1, we'll put the -2 here. When you add it back to +2, you'll get a 0. Okay, so for my fourth matrix, the row operation to get it is going to be -2 times row 1, add it back to the third row. That's going to be the new third row. Okay. All right. So new matrix. Okay. From the previous matrix, row 1 will not change. Row 2 will not change. Okay. Row 3 is the guy that's going to change. So let's go out to the side and do the work. Okay, we're going to do -2 times row 1. Okay, so we're going to get, let's see, -2, -4, negative times negative is +2, and then we'll have -6. Okay, and we're going to add row 3 back to it. Okay, all right, so let's see here. Go back to the previous matrix, write down row 3, and now we can add these guys together. Okay, all right, let's see what happens here. We're going to get -2 plus 2 is 0. -4 plus 4 is 0. 2 plus a -2 is 0. And then -6 plus 10 is 4. So here is our new third row. So we are done with the first column. Okay. So now we should move on to the second column. Secure a 1 on the main diagonal. It already is, which is great. Okay. So now we can work on zeroing out the rest of the column. Okay. So you should go on to the next step, okay, and try to turn this 2 into a 0, okay? But perhaps you've already recognized what's going on here, okay? After we completed column one, look at what we were left with, okay? Look at this particular row, okay? Do you recognize that? Where you have one of your rows and to the left of the vertical bar, you have all zeros, and then you have a non-zero number on the right side, okay? If you recognize that, you don't have to go on, okay? How is this going to translate? Okay, if you take this yellow highlighted line here and you change it back into an equation, okay? Remember, this column, these are the numbers in front of x. Second column, numbers in front of y. Third column, numbers in front of z. If I translate this guy, this is 0 times x plus 0 times y plus 0 times z is equal to 4, okay? Anything times 0 is 0. So this entire left side cancels out, and I get 0 equals 4. That's a nonsense statement. 0 can never equal 4, okay? So that tells you this system has no solution, okay? Had you not realized this, okay, and you kept going and you zeroed this out, that's fine, okay? You would have eventually gotten to a final matrix and you would end up in a situation like this, where you have the same type of row at the bottom with zeros on the left and then a non-zero number on the right. So you still would have gotten there. You just had a couple extra steps, okay? But anytime you're in your process and you see a row that looks like this, where one of the rows has, all zeros on the left side of the vertical bar and a non-zero number on the right, okay? That translates into some kind of nonsense statement like 0 equals 4. And that doesn't make any sense. So that implies that the system has no solution. Okay, so at this point, we can just write down this system has no solution and we can move on to the next one. Okay, so again, what does that mean? Okay, that means that there is no x, y, and z variable assignment that is going to make all three of these equations true at the same time. Just does not happen. Okay. All right. Let's go on to the next one.